Check this.
Okay, welcome back. Today we're going to continue talking about operations on radicals. Today we're going to be multiplying radicals. So last time we were adding radicals and any kind of roots, in other words. And we had to make sure that the inside of the root and the outside of the root match before we could add anything or subtract anything. So for instance, if you have radical 5, you could add it to another radical 5, and then you would have 2 radical 5s. Or if you had, I don't know, 3 radical 5, some multiple of this, and another multiple of this, like 8, then 3 plus 8 would give you 11 of them, 11 radical 5s. It works exactly like you would if you had an x, like 3x plus 8x equals 11x. And you can't add unlike terms, so 3x plus 8y, you could not add those, right? So the only way they were like terms is if the radicals were exactly the same. But with multiplying, they don't have to be exactly the same. They just have to be the same root. So as long as they're both square roots, you can multiply them. Or as long as they're both, I don't know, 4th roots, you can multiply them. You can't mix and match. You can't multiply a square root times a 4th root. But as long as they're the same root, you can multiply the insides, no problem. So multiplication is actually less restrictive. You don't have to simplify stuff before you multiply. You do have to simplify everything before you can add or subtract to make sure they're the same root. So let's take a look at an example here. We have some multiplication. Okay, we want to multiply this times this. Now you notice they're both cube roots, so we're good. There's a negative in here, but that's fine because it's an odd root, so that's not a problem. And we have numbers outside of the radicals as well. So if you have numbers outside, that's okay. Multiply the outside stuff first. So 5 times 3, that's just going to be 15. That's the outside numbers. Now the inside numbers, the stuff inside the radical are just going to end up inside of one big radical. So what's negative 12 times 18? Well, you can grab a calculator if you don't know what that is. 12 times 18 is 216. So this is negative 216. You have an a here, an a squared here. So a times a squared is a cubed. You have b to the 4th times b squared. You add the powers to get b to the 6th. So that's the multiplication step. But you're not done until you finish simplifying completely. So just like with the last lesson, you're going to have to chop this up, okay? And you're going to have to find out what this is when it's simplified. So let's break this up. We have the 3rd root of 216, the 3rd root of a cubed, and the 3rd root of b to the 6th. Okay, now, what is the 3rd root of 216? All right, well, it's negative 6, but if you want to know how to do this with a calculator, okay, just to review how to do that, you type 3 for 3rd root, then you find on your calculator the button that says x root, which in this case is in the menu here, and then you type in, well, negative 216, and you get negative 6, okay? For older calculators, you might have to put the 216 in first and the 3 in last, but that's how you do a root. So this is negative 6 right here. Now this right here, a to the 3rd power, 3rd root. You're supposed to divide power by root, so 3 divided by 3 is 1, so this is just a to the 1, which is just a. And this is 6 divided by 3, which is 2, so this is b squared. Okay, now 15 times 6 is 90, so this is negative 90 ab squared, and we are done with that example. All right, let's try one with a 4th root here. So this is a 4th root. We got a 2 here and a 3 here that are outside, so let's multiply the outside numbers. 2 times 3 is 6. And now whatever we get by multiplying the radicals becomes a 4th root. Once again, they have to be the same kind of roots, so there's no way that you're going to have 2 different index numbers. They're both going to be 4. So it's one big 4th root. And now we multiply the insides. Well, 8 times 2 is 16. X to the 3rd times x to the 5th is x to the 8th. Y squared times y squared is y to the 4th. So that's your first step. That's the multiplying step. Now the simplifying begins. So we have a 6 outside, we have a 4th root of 16, we have a 4th root of x to the 8th, we have a 4th root of y to the 4th. Okay, and luckily these all come out to be nice and clean, nice and easy. So 6, 4th root of 16 is 2. 2 times 2 times 2 times 2 is 16. This is 8 divided by 4, the power here, so that's x squared. And this is 4 divided by 4, which is y to the first. We don't write the 1. Okay? Now, you need to look at the original problem to decide if there are any bars. Okay? In the original problem, let's just take a look at the one we did before here. In the original problem here, you had an a that was an odd number. So you don't have to worry about going from even to odd, because if a was negative, it would have shown up here. So notice I didn't put any bars here at all. B, both of these b's were even, so if there was a negative, it would be hidden, but I ended up even anyway, so even to even, no bars. But in this case here, for the x, we ended up even, so no worries. But for the y, both of these y's were squared. So if there was a negative number for y, it would be hidden because of the fact that it's an even power. And now we end up odd, so there are going to be absolute value bars around that y. Okay, so this is 12 right here. So 12 x squared, absolute value of y, and we are done. Okay, in this section, I'll be honest with you, I'm not going to harp on the absolute value that much. So if you didn't think of, because it is complicated, the fact that there's multiple y's up here. So I'm not going to mark you wrong in this particular section on the homework. But later on, when there's a single thing, like in the previous lesson, you do have to do the absolute value bars. But for tonight's homework, I'm not going to worry about the bars. Let's just put it that way, just for tonight's homework, because there are multiple terms and you're multiplying. Okay, so that's done. What about multiplying binomials? Okay, binomials meaning you have two things, okay, rather than singles. So let's take a look at that. So here we have a binomial, meaning one term plus another term. And here's another binomial, one term minus another term. And when you're multiplying two binomials, you need to basically distribute, what we used to call FOIL. So 4 radical 3 times both of these over here, and then 5 radical 2 times both of these over here, and then combine like terms and simplify as much as possible. So let's multiply 4 radical 3 times 3 radical 2. Remember, the outside numbers go first. So 4 times 3 is 12. Now inside the radicals, these are both square roots. Radical 3 times radical 2 is radical 6. That one's done. Now 4 radical 3 times negative 6. Okay, here's the outside number 4, and this is an outside number, negative 6. Okay, so that's negative 24. Now for the inside, there's a radical here, there's none here, so just basically copy this one down. Or you could think of this as 6 radical 1, and the negative radical 3 times the radical 1 is radical 3 still. Either way, doesn't matter. Okay, so now we come over here, 5 radical 2. 5 radical 2 times 3 radical 2. 5 times 3 is 15. And radical 2 times radical 2 is radical 4. We'll come back to that later, obviously. And then finally, 5 radical 2 times negative 6. 5 times negative 6 is negative 30. And there's a radical 2 there. Okay, now we look for anything we can simplify. This right here is a perfect square, so that becomes a 2. So other than that, nothing else is going to be the same type of radical. So we have 12 radical 6. We have negative 24 radical 3. We have this 30 radical 2 here. Okay, and this is just going to be 15 times 3, which is 30. None of the radicals match, so I cannot add any of them, because for adding, you have to have the same type of radical, and you have to have the same inside. None of these have the same inside, so we're done. They're all simplified. You can tell that they're all simplified because 2 is a prime number, 3 is a prime number, 6 is not a prime number, but if you do a factor tree, you just get 3 times 2, right? And 3 times 2, neither one of them have, is a perfect square, so you're done. Okay, let's try another one here. Now we have 6 radical 3 minus 5 times this binomial over here. And once again, we're just going to distribute, right? The same way we did in the last example. 6 radical 3 times 2 radical 5 is the first thing we multiply. So 6 times 2, the outside numbers, that becomes 12. And then radical 3 times radical 5 is radical 15. Okay? Now 6 radical 3 times the thing over here, 4 radical 2. 6 times 4 is 24. Radical 3 times radical 2 is radical 6. Okay, we're done distributing the 6 radical 3. Now let's distribute the negative 5. Negative 5 times 2 radical 5. Negative 5 times 2 is negative 10. There's no radical here. There's a radical 5 here, so just radical 5. Like I said, you could also think of it as like radical 1. And then when you multiply the radicals, you get that, but not really necessary. And then negative 5 times positive 4 radical 2. Negative 5 times 4 is negative 20. And there's only a radical 2, so just bring it down. Okay, now you look to see if there's anything here that we can simplify. 2 and 5 are prime numbers. You can't factor them without getting those. They have no factors other than themselves and 1. So prime numbers you don't have to worry about breaking down. 6 and 15, however, you have to check. 15 is 3 times 5, and neither of these will square root without giving you an irrational decimal. So 15 is fine. That's already simplified. And 6, as we said a few minutes ago, is 3 times 2. They're both prime, and there's nothing here you can square root either. So 15 and 6 will remain. Now you look at it and say, is there anything here, is there anything here that I can add together, any like terms? Well, you have a 15 inside the radical, a 6, a 5, and a 2. None of them match, so you're done. Okay, if they match, then you can add them or subtract them. But they don't match, so you are finished. Okay, let's try another one. Now this is not a binomial times a binomial. This is a monomial, meaning one term, times another single term. All right. Even though it looks complicated, this is only one term, and this is only one term, just like the problem we did at the beginning of the lesson. And once again, you multiply the outside numbers first. So 6 times 4 is 24. And then what's inside the radical? Well, they're both square roots, so you're going to get one big square root here for your first step. And this is 8 times 2, which is 16. C to the third times C, which is C to the fourth. And D to the fifth times D to the third. You add the powers, 5 plus 3 is 8. You get there. Now the 24 outside is just a spectator, it just stays there, it's a multiple. And we're going to break up the rest of these into separate roots. Now, as usual, a square root has the implied index number of 2, the invisible one we don't write. Okay? And we all know what the square root of 16 is, hopefully, right? It's 4. And this is going to be c squared, and this is going to be d to the fourth. So 24 times 4, 80 plus 16, 96. C squared, d to the fourth. And we're done. No need for bars. For two reasons. One, we landed on evens, right? No even to odd. But also we started off as odd. All these were odd to begin with. So there's no way. It went from odd to even, basically, and nothing to worry about there. Now the last one here is going to be multiplying binomials again. So we're going to be, distributing FOIL. But if you take a look a little bit more closely here, you'll notice that these are conjugates, okay? And conjugates are special because something interesting happens when you multiply conjugates. Conjugates are binomials that are identical, except the only thing that's different about them is their middle sign is different. So aside from that plus and that minus, these are exactly the same thing. Now we ran into conjugates when we were doing complex numbers. 3 plus 2i and 3 minus 2i are conjugates. And the reason why those were important were when you multiply two conjugates, all the i's went away and you got, well, let's do it real quick. This is going to be 9 minus 4i squared. So 9 plus 4, which is 13. You got a number with no I in it. You just got a simple answer that was just a number, no imaginary stuff. And what's great about conjugates with radicals is that you will also get a number. I don't know what the answer is yet, so I'll just make up a number, 15. You'll get a single number answer. Of course, you still have to show all the work, but I'm saying that all the radicals will disappear when you're multiplying conjugates, just like all the i's disappear when you're multiplying complex conjugates. Okay? So conjugates, whenever you can get them, are a good thing. Okay? And also when you're multiplying conjugates like 2 plus 3x and 2 minus 3x, okay, you get that shortcut where you don't have to do the full FOIL. You just multiply first times first and last times last, and you get like 4 minus 9x squared. Really quick stuff. So conjugates are always great because they lead to a shortcut. Okay, so in this case, let's see what happens when we multiply the conjugates that are here. 7 radical 2, I'm going to distribute that first. 7 times 7 is 49. And radical 2 times radical 2 is radical 4. 7 radical 2 times 3 radical 3. Well, 7 times 3 is 21. And radical 2 times radical 2 is radical 6. Okay, we're done with the 7. Now let's distribute the negative 3 radical 3 to both of these. Negative 3 radical 3 times 7 radical 2. Negative 3 times 7 is negative 21. Radical 3 times radical 2 is radical 6. This times this now. Negative radical 3, negative 3 times positive 3 is negative 9, and radical 3 times radical 3 is radical 9. Now this doesn't look that simple, but take a closer look. This right here is a perfect square. This is the square root of 4. It's going to become a 2. This right here is a perfect square. That's going to become a 3. And these two in the middle here, they're exactly the same, but one's positive and one's negative. So when you add them together, and you can add them because they're identical, right? Same type of root and same number inside the root, they cancel each other out. So what's left? 49 times 2 is 98, and 9 times 3 is 27. And what you end up here is you end up with 71. A simple number with no radicals in it, which is what I predicted, because when you see that they're conjugates, that's going to happen. Everything, all the radicals will cancel out. Okay, last one here. So we got ourselves two monomials, okay? So these two monomials, one term here, there's no distributing, right? And let's just multiply it and see what happens. So this is a lot like the last, we did 2 of these already. Let's do another one here, or actually I think we did 3. So outside numbers are 5 times 5, which is 25. Simple enough there. And they're both square roots, so you're going to get one big square root. And now let's see. You have this thing, x to the 8th, y to the 3rd, times 2x to the 5th, y to the 4th. There's no number here, so we can assume it's a 1. And 1 times 2 is 2. Then you have x to the 8th times x to the 5th, which is x to the 13th. And then you have y to the 3rd times y to the 4th. You add the powers, you get y to the 7th. Okay, so just like all the other ones, you just multiply. But the simplifying here is going to be a little bit more complicated. So we're going to chop this up now into 3 different roots. We have the 25. We have a square root of 2. We have a square root of x to the 13th. And we have a square root of y to the 7th. Now with all square roots, it's implied that there's a invisible 2 here. Now, 25 is done. We'll leave it out here. Square root of 2, okay, we don't need it. Well, here's the thing. It's a power of 1, right? And this is a 2. If this number is lower than this number, then you can't do anything with it, right? And you can't factor tree it either. So it's just going to stay as square root of 2. Radical 2. That's not going anywhere. 13, however, 13 doesn't divide by 2. 13 divided by 2 doesn't work. So what happens, like we saw in the last lesson, what happens when you can't divide, as long as you're higher than this number, you can start coming down 1 power at a time. So 13 doesn't divide by 2, but 12 does. So let's change this to an x to the 12th times x to the 1st. Now we don't usually write the first, so I'll put it there in red. But 12 will divide by the invisible 2. 1 won't, so this is going to stay the way it is, but 12 will. Okay? And how about 7? 7 doesn't divide by 2. So you come down from here and you try y to the 6th. Okay? Y to the 6th, 6 will divide by 2 evenly. But then you have that extra y, okay, technically to the first power there, that you need 6 plus 1 equals 7. You need that. Okay, so don't just change it to 6 without, you're factoring as what you're doing. You're making it 6 and 1 to give you 7. Okay, and then you go and you simplify whatever you can simplify. So 25 is already done. Radical 2 is already done. This becomes x to the 12 divided by 2, which is x to the 6th. This can't go anywhere, so this is already done. Radical x here. This is going to be 6 divided by the invisible 2, so 3, y to the 3rd. And this is radical y. That's not going anywhere. And now, the way you write your answers, it's always the same workflow here. It's numbers first, then letters, then absolute value bars, then radicals. That's the hierarchy. This is the order you have to write things in. So we already know that you write 7x, not x7. So numbers and letters we already know for a long time. If there are absolute value bars, they go after the letters, after the variables. Okay, anything in absolute value bars. And if there's any radical, that goes after the absolute value. So let's see, numbers. Well, we have 25. Letters that are not inside radicals would be these, right? And then finally, the stuff in the radicals would be this radical 2, radical x, and radical y. You basically put them all in the same radical. So 2 times x times y, 2xy. And we're done. Okay, that's it. See you at the next video.
Check this.